Python list comprehension. Or okay, so we're going to talk about Python list comprehension here. Uh, Comprehension in Python, what it does is it offers a concise and efficient way to create collection types. So in that sense, we have list comprehension, we have dictionaries comprehension, we also have set comprehension. Okay, so what we're going to be exploring here in this tutorial is list comprehension. In subsequent tutorials, we're going to delve into other aspects of comprehension. Um, what comprehension does, it's like I said, it offers us a concise and efficient way to create collection types. Okay, um, I think this is better demonstrated than explained. If we have, say, I have square for instance, then I set square to empty list. Of course, in order to use this list, I have to populate it, and then the way we populate is to invoke the uh, append method. So I could have for high in range. Okay, let's do range 10. Then I can have square dot append. Say I have uh, high exponentiation 2. That's how we get our square. Anyway, okay. So then if I do square, sure enough, we have our square. Okay, maybe I should have used squares there. Anyway, you get the idea. So we went from 0 to 9, like we said in range. The last index is omitted anyway. Okay, so 0, index of 0, square of 0, 0, 1, square of 2, 3, on and on till we get to 9. Okay, now you would expect that at this point, this high, this variable high, which is referencing our int object, you expect that okay, it should have been exhausted, but it turns out that this approach causes what is known as side effects. And side effect in programming is when you have a code modifying another code in outside of its lexical scope. Okay, so here we still have access to our high variable. We still have access to the object that our variable high references in this lexical scope. So that if we do high, see, we get 9. 9 is the last index on the last number in our range. When we square that, we got to this. So this causes side effects. Okay, so the way we fix this is to use comprehension. Okay, so pay attention. If I use comprehension, I can do squares. This is comprehension. This is list comprehension. Okay, so usually comprehension starts with an expression, then some kind of condition after the expression. It could be a single condition, it could be 2 conditions, it could be more, for, if, as the case may be. So if we were to recreate this program that we use in populating our square list, then we can do, if we want to, we're not going to stick with high because high is still going to be in this lexical scope. So I'm going to use J here. So J exponentiation 2 for J in range. So we do range 10. Okay. And then if I do squares, sure enough, we'll get this. Now the other time, we recall that after we generated this, we still have we had access to the object that is I variable was pointing to. Now here we've switched to J. We're using comprehension. Now let's see whether we still have access to the object that J references. See, we get an error. So this, our comprehension does not cause side effects, unlike the other regular program. So that's why we're getting error here. It says J is not defined, which is good. So comprehension offers us a concise and efficient way to create collection types in Python. So I'm going to go back to my squares, and then that's what I have. Okay. It's not only this that we can do. We can also have, let's have fruits, for instance. To drill this in, say apple, and then we could have banana. I don't know. So we have mango. Okay. Then let's say new. Okay, let's stick with new list. Then we have a comprehension here. Remember, we said we have an expression and then some kind of condition. Okay. Then say we have F. No, go back. Sorry. F. Then our condition for F in fruits. Okay. So we also said we could have, apart from for, we could have some kind of if statement as the case may be. Okay. So then let's say we have if A in F. So here we are trying to say, okay, what we're saying here is, okay, we're trying to create a new list with this condition inside our list comprehension. So we start with an expression F. Then we say for F in fruits, if this character A is in F. So this is like identity now. Remember when we did object identity operator. Okay. So here, if I do new list, sure enough, we got the items that have letter A inside our list. Oh, what did I do? I'm returning everything. I'm going to have to do that again because, okay, so every item here has letter A. What if you do fruits dot append, and then here I do cherry. Then I do fruits. Okay, so I can do new fruits. Then I do X for X in fruits if A in X. Okay, like that. And if I do new fruits, say cherry does not have letter A, so it's not part of our new list. Okay, when we use our comprehension. All right. There is more we can do with our comprehension. So maybe to demonstrate that, let's say maybe we go back to our, what is it called? We go back to our numbers to demonstrate that. Okay. If we have, we could create a list of tuple, okay, with comprehension. Okay, let's see. List tuple. Is it list tuple? Okay, list tuple. It's not It's not an awkward name. Then we could have our dictionary here. Sorry, our comprehension. Then we could have, remember we said we start with an expression, xy. Then for x in, so we have our list, 1, 2, 3. Okay, like that. Then for y, remember we had xy. So for x in this, then for y in this time we have, let's have 3, 1, 4. Okay, like that. Then we can also have some kind of condition. Let me say if x is not equals to y. Let me give it space. If x is not equals to y. Alright, so let's see what we get. If I do list tuple, see we have a list of tuples. Okay, so that's another thing we can do with comprehension. Okay, what else can we do? Let's do for matrix. Let's do for matrix. We could have matrix. Okay, we could have matrix. Then we have this. Remember how our matrix work. Okay, so we could have 1, 2, 3, 4. Okay. Then we have 5, 6, 7, 8. Then we could have 9, 10, 11, 12, like that. And then we have to close this. So that's our matrix, right? So this is, what do we call this? This is 3 by 4 matrix. 3 rows, 4 columns. 1, 2, 3. 1, 2, 3, 4. Oh, so sorry. This is like, there's 2 digits here. So 1, 2, 3. Then 1, 2, 3, 4. So 3 by 4 matrix here. Okay. Now, what if we wish to transpose this matrix? Remember, when we transpose a matrix, our rows become columns and our columns become rows. Okay, that's the rule for make the matrix transpose. For transpose, matrix is it transposition now? Okay, now so when we transpose this matrix, what's going to happen is our columns are going to become our new rows. So if we were to transpose this now, we could have 1, 5, 9, then 2, 6, 10 for the second row, 3, 7, 11 for the third row, and then 4, 8 for the fourth row. Okay, so how do we go about that? Okay, we're going to have TR, short for transpose. Then here we could have our comprehension. Then let's say let's have a list here. Then we say row high. That's for the row. Okay. Then we can say for row in matrix. Okay, for row in matrix. Okay, so that undo our row. Then we have to go to the columns. Then we can do for high in range. Now remember, we have 4 columns, right? 4 columns, so range 4. Okay, like that. So what do we get? If I do see how, see, we have transpose of our matrix. The first row is 1, 5, 9. So our column has become our first row. So this is, we went from 3 by 4 matrix now to 4 by 3 matrix. I don't know if I do print, does this work? TR, and if I do this, line, it doesn't work in here in this Python environment. Okay, but then you get the idea. So remember, initially this was our first row. All right, 1, 2, 3, 4. Now our first row has become our first column. So 1, 2, 3, 4. This was our first column, 1, 5 now. Now our first column, our column has become our new row, first row. So 1, 5, 9. Like that. Okay? So that is list comprehension. List comprehension offers us a concise way to manage our collection type. Okay? I don't want to delve into the whole lambda thing because we've not actually gotten to that spot yet. But then I hope for the little demonstration that we've had here, I hope you've learned one or two things regarding Python list comprehension. Okay, maybe we should do one more. Say we want to have a nested comprehension that flatten our list. Okay, so here we did transpose. Okay, so say we wish to flatten this transpose that we have, then we could have flatten. Okay, let me just say flat. Then we have our comprehension. Comprehension here. Then let's say we have var for row in t-hat in transpose. Okay, then for var in row. This is going to flatten our transpose list, hopefully. So if I do flat, see, now we get all the items flattened. Okay, remember, so 159, 216, 3711, 4812, like that. So our transpose list, our transpose matrix has been flattened to a regular list here. Okay, so I think I'm going to stop here, and I'll see you guys in subsequent tutorials. Thanks for watching.